Hey, welcome to the CTO Studio. Today we talk to Khai Pham, the CEO and founder of ThinkingNode, a new way to think using AI, not machine learning, but AI.
Well, I have a wonderful electronic invention I want you to see. It looks something like this.
Welcome to the CTO Studio. I'm your host, Etienne de Bruin. The CTO Studio is where we chat with CTOs building amazing products with incredible teams. Have you chatted with a CTO lately? Khai Pham, welcome to the CTO Studio.
Happy to be here.
We have been flying around each other for a couple, I think is it probably a year or two now?
Yeah.
And I've observed you preach sort of a message around AI and thinking about AI, and also seen you build ThinkingNode. So I want to dig into all that stuff because AI. I'm tempted to ask you, hey Kai, what is AI? But I thought I would start with what is ThinkingNode, and then maybe you can unpack a couple concepts for us on what that is.
Yeah. So today you heard a lot of time people talk about AI, machine learning, but at the end they only talk about machine learning. Even though, of course, AI is the general domain that encapsulate machine learning. Today, most of the AI machine learning application is about big data, pattern recognition. And the goal of that is to build predictive system based on statistical approach. And this give you correlations. And one thing that is very important, even though you learn that in Statistic 101, correlation is not causation. And the holy grail of any science is about to find the causality of things. And from data, you will never get correlation. So you need...
From data, you never get causation.
From data, you will never get causation.
And to just decipher that is really to take action on data, right? To do something based on big data, right?
Yeah, if you are purely data-driven, the misconception with people, they think that, if I have enough data, I will be able to solve it. If you do a self-driving car, yes. If you are working in life science, understanding, drug safety, discovery, biology, and so on, no. Because you need knowledge, you need to have a causal model to understand what's going on, and then you can act on it. So this is a very important difference.
So how is that different then from self-driving cars? Because I think most people understand sort of what that is.
Yeah.
A car still has to use a lot of data to make decisions on what to do next. Isn't that causation?
Yeah, no. So first of all, you have to train the system. So you use a lot of data. And to give you an idea, for 1 hour video that you can use to train the self-driving car, it asks 800 hours of human being to annotate it. So it needs a lot of data to train the system to find some pattern and based on correlation. And a self-driving car just do reaction. It doesn't do any reasoning or thinking. So the soonest you start to get into the reasoning and thinking, where you have to, think on several steps, having some hypothesis and question and assumption and so on. This is reasoning, and this is what ThinkingNode we are doing, reasoning computing.
So causation in self-driving cars is the car basically deciding where you need to go based on certain behavior. It reminds me of a Douglas Adams book where I think it was The Hitchhiker's Guide or one of the series, where the elevators could, in order to be super efficient, they could see into the future so that they could, when you got into the elevator would know which floor you needed to go to.
Okay. Yeah, no, this is strange because people confuse most of the time between pattern recognition and reasoning, even though we are doing both in our life. But when you want to solve a problem, it's about reasoning computing. And what is very interesting right now is Julia Pearl, who is one of the reference in AI. I mean, he set up the Bayesian network, really a reference in machine learning. 2011, he got the ACM Turing Award, which is the equivalent of Nobel Prize in computing. Write a new books and is quite vocal about explaining machine learning is not enough. We will never get there if we don't have the reasoning. So ThinkingNode is really about that, because I had the experience. I was pioneering machine learning and data mining with one of the best exit. I mean, we had $400 million exit, which is the second highest after DeepMind. So I understood very well the limitation of that. So it's why for years now I'm on the reasoning computing.
And so you decided, just to wrap up the ThinkingNode story, you decided you wanted to tackle using data for causation.
You cannot use data for causation. You have, first of all, to have a model of the domain that you are working on. So for example, if you are putting me into finance, you give me a bunch of data and super machine learning, I don't know what to do with that, because I don't have the expertise and the knowledge and the model of that. So human, we have a mental model in each domain that we are. And we are using this mental model to think, to have hypotheses, and to act on it. So our mental model represents the world. And with the mental model, we can play with that and say, okay, what if I'm doing that or that? So the mental model will give you some answer, which give you a certain probability that it's going to be the same on the world, because your mental model represents the world, the domain where you are.
So when you talk about the model,
yes.
Are you saying, is that what learning is?
Yes.
So you take the data, you build the model based on learning.
Okay, so you have different kind of learning. You have the learning through the data that build you a model, but it's not a causal model. It's just a correlation model. You must make an association between an input and an output. So the only thing that it provides is a prediction.
And then that's where it sees the patterns, and it's sort of based on all the data, we draw these correlations.
Yes.
Therefore, we can see in other new data, the same sort of correlations.
Yes.
Okay.
So this is the pattern that you can have. It's not really a model. I call that a pattern.
Okay.
The model is you have in your mind, in your domain. If you are, genetician, or you are physician or financial guy, you have a model of your domain of expertise. And using this data allow you to optimize this model, to update it. So it's like, a scientist, you have a specific model on this at the cellular level, and you do a new experimental data. This experimental data will help you to update this model. And people don't think about it because we have this model in our mind. So we think that just data, we are going to solve it. No, we use the data, and then we use our internal model to interpret it, to make sense of it, and then we can solve the problem.
And so does ThinkingNode go into all these domains and build these models as a service or as a value?
Yeah, exactly. So we are working with partners to build this different model. And this model can be built in different way, either through the expert or through some database. And what is the secret sauce of the model? For example, for a big pharma or biotech company, of course, this is keep it private, but all the public knowledge around that, then we hosted all this public knowledge so everybody can benefit from that. So we provide what we call a thinking as a service, or another way to put it, you have stock market exchange. We want to build an expertise market exchange, and then using blockchain to allow us to monetize it, because each concept.
Oh my goodness! You just said blockchain.
Okay.
Why?
Sorry.
Because you're raising money.
No. Well,
We use AI.
Yes.
We use blockchain. Boom, sign the checks.
No, and it's enough to say AI in biology. So
Is that enough?
Yeah. No, it's about how to monetize the expertise to trace back which concept belongs to whom.
Okay.
You
so
can
the audit trail.
Yeah.
So if I publish my
thinking
model
network
to your service or
Yes.
marketplace,
Yes.
and it gets used by X number of
Exactly.
customers, you can trace that back, which is a classic application of blockchain. Okay.
Yes.
Thinking as a service. Did
Mhm.
you invent that? THOS.
Yeah.
Do you have those domains?
I don't have those domain.
Great. So, can you give me a practical example of the customers that you can talk about? Just brute force, like what do they bring to ThinkingNode? What do you do, and how have they been able to apply that in their domains?
Yeah. So, for example, we work with Craig Venter Institute, amazing team with the synthetic biology group, and we're working on one of the project is to better understand in detail why some genes are essential for life, and we are using their own knowledge, but the combination is enormous, as you can imagine. So by uploading their knowledge, we were able to combine all these kind of different concepts and explain why some genes are essential for life. Because something is very important. AI in reasoning computing exists for a long time, but the existing technology cannot scale. And one of the reasons is because they try to reproduce how the experts solve the problem. And when
the human.
Yeah, the human.
Yes.
And when you do that, you get into an explosion of combination because it depends. So we are focusing on how the expert organize his or her knowledge, not how it's solved. We let the system solve it. So we just take piece by piece the different knowledge and the system combine it, because as a human, we can only combine 5 to 9 concepts at the same time. So we underuse dramatically what we know. It's like 20 years ago when I was saying to the people, you can extract knowledge from data. What are you talking about? So today what I'm saying is you can extract new knowledge from existing knowledge. And this is enormous because knowledge is gold, data is rock. So there are so many available knowledge that we cannot tap into.
So speaking about the Craig Venter application, how is that not just a correlation where you're looking at all this data, you find the genes I'm assuming some sort of pattern of a gene's presence. So how does ThinkingNode then extrapolate which genes are necessary for life in that scenario? That is different from just standard sort of mining data and learning pattern recognition.
So first of all, when you have a correlation, if you have A that is correlated to B, you don't know if A is the cause of B or B is the cause of A, or they are just there by coincidence. So you have no notion of causality. So in this case, they have the knowledge that this enzyme has an impact on this reaction, which has an impact on the production of this metabolite, which has, and so on and so on. The problem is to combine all of that.
So it's not just, a new way of bulldozing through data and then finding the matches at all. It's more, like you said, the knowledge produces knowledge.
Yeah, combining all that, and then you can infer new knowledge. For example, in insurance, for car insurance, it's well known that, if you, today they change it, but when they were using statistical approach, machine learning or other things, when you have a red car, your cost can be higher because there is a correlation with red car and the number of accidents. But red car is not the cause of having more accidents, it's because it's more sport car and so on. So this kind of conclusion, you can get into stupid things. Now, I'm not throwing stone on machine learning, right? It's amazing, and I'm part of it, and I will continue to be part of it. What I'm just saying is it's not enough. And in certain domains, such as life science and so on, where there's a lot of knowledge, you need reasoning computing to have a causal model to work on it.
So the Craig Venter Institute has successfully, therefore, used your approach to to gather the genes that are necessary for life. Is that
yeah? So they have the list of the genes, but it's here. The exercise was, okay, can we go into detail exactly what's going on?
Okay.
And we work on other projects. I cannot give them because it's confidential. But on drug safety, we work on diagnosis for genetic rare disease. We work on how to identify new genes that can be cause for some disease. And we work on genetic engineering to produce different products, so biofuel or this kind of thing.
Two questions. So let me just ask you. You're doing all this amazing work around life and medicine and all that. Do you think AI can be used to help determine whether a software team will deliver software on time?
Well,
through causality?
The thing is, causality means to be really rational. You see what I mean? So
therefore,
human is not always rational. We have mood, we have hormones.
Amazing.
We are driving by.
If I think about the number of times a CTO has to defend why something is not being built within the specified amount of time.
Well, for me, when you want to do amazing things, not the regular thing, but the amazing things, it's a mindset. It's not the technology. Because when you are in the right mindset, you will find the solution. Otherwise, you're going to say, no, it's not possible or whatever. So there are a lot of components into why you deliver it.
The second question I had was, for someone who is wanting to get into AI, true AI.
Yeah.
Are there platforms as a service or basic SaaS products out there that you can recommend? I'm thinking like TensorFlow for machine learning.
Yeah.
Is there, even in ThinkingNode, are there just basic tools that we can sort of get involved with?
On machine learning, you have quite of them. On the reasoning computing, the only thing you have out there is, like I said, the old technology, like rule-based system or these kind of things that cannot scale for a number of reasons, and because it cannot manage several logic at the same time. ThinkingNode, we do not have that yet as open source because we want it, managing open source is not just you put it open source and let it go. It's a lot of work. So we want, first of all, to build a company and so on, and then later on.
Yeah, you want to build THOS.
Yeah.
Can this be the first public announcement that you're building THOS?
I don't know. I would not go there.
So what I love also about you, I have a close friend who's was born in India but was raised in Scotland, and so he has this an Indian-looking fellow who is who sounds like a Scotsman.
Yeah.
And you are Vietnamese,
yes,
but raised in France.
Yes.
So you have this delicious French accent.
I don't know. Well, my problem is I'm losing, of course, my Vietnamese. I start to forget my French, and my English will never be perfect. So
I think your English is perfect. So just give us 2-3 minutes. Let's dive into where Khai Pham's origin story. Take us through how you got to this place.
Well, yeah. So I was born in Vietnam. My mom, who is my role model, always said to me, "You have one head, two hands, and two legs as everybody. You want to do something, you must be able to do it. Maybe not straight, but you will find your way." So this stick in my mind. So I grew up in France. I did my MD, PhD at the University of Paris.
So did education take you to France?
Yes.
And
I arrived when I was 7.
Okay. And then were you in Paris?
Yes.
Okay.
Yes.
What is your favorite place in Paris? Speaking to tourists.
Oh, there's so many.
What's number one?
Montmartre.
Oh, I love that place. It's the only place where I think I spent $20 on a cappuccino. I love it.
Okay.
It's also
Yeah.
Salvador Dali's museum is right around the corner. I love that area. Okay,
Yeah,
so then you got your PhD.
Yeah, so, well, at the second year of medicine, I don't have much memory. So can you imagine how much I suffer in medicine? So I said to myself, I mean, the machine should solve that. So I went to see the AI expert guys at that time, and they said, yeah, you will have if A and B, then C. So I said, yeah, no, sometimes you don't have A, you're not sure about B, but you know, oh, but this is because you're a student. When you will be physician, everything will be clear. So I was not convinced at all. So I decided to really think about how I'm thinking. So for 25 years, I'm thinking about how we think. So then I designed a system to handle that, because most of the time the AI technology start with a formal system that computer scientists define, and then they try to fit into that how we think. I did the opposite.
Because and this is this gets into computer languages as well, where am I trying to tell the computer what I am thinking, or am I trying to change my thinking so that the computer will understand?
Exactly. So ThinkingNode, the foundation of the structure is really based on how we think, more than how a formal system should work. So it's why it took me the first year, 3 years, to stabilize just the system. But so doing that, so coming from Paris University, Pierre-Marie Curie, same university, for example, with Yann LeCun, the head of AI, Facebook, it's a very strong university in that. The president of the computer science said, okay, if I'm right, I'm going to change AI. Who want to check that? So of course I was student, nobody. So naively I say, I'm going to start my own company to prove that. And at the time I didn't even know business plan term existed.
And this is, when is this? Is this like the 80s? Or?
No, this was in 92 something. Yeah.
Okay.
So the technology allow you to unify actually machine learning and reasoning computing. So I pushed that out on the market because I have no clue which one is going to take off. So we solve very complex problem in missile design and so on for the reasoning computing. But I saw at that time it was data warehousing. So the next logic step of data warehousing is data mining machine learning. So, and we saw that financial institution, just take it, go. So I decided to shut down the reasoning part and just only focusing on the data mining machine learning. So this is the first company.
Okay.
And today, I have...
So did that take you to San Francisco?
Yes. So I've been 15 years in Silicon Valley, and I moved to San Diego to be closer to the life science community.
Okay.
Because, it's amazing what happened, the last 3-5 years in life science. So it's a perfect time to combine reasoning computing with life science. So it's why I come.
Do you, so just to get to know you a little bit, are you driven by serving life sciences because of what? To eliminate like disease, to prolong life, to travel to other planets? What if I was to ask Khai Pham, like, why is this so important to you? What would you say?
Life science, without life, nothing else exists. What I mean by that is...
Dun, dun.
No, because, the earth would not exist without life. And what I mean by that is there is no life to have a concept of earth. So what I mean is it's so fundamental. But I'm not only interested in life science. I'm very interested in space, for example. So if we are serious to go to Mars and so on, we need AI to help us to go there. But at the same time, how to build something that can be alive through biology and so on over there. For example, how to produce molecule on demand, because you cannot go there with all the molecule you want, for example. So for me, today, to have the biggest impact on this planet, money will never be enough. Education takes time. It's the access to expertise. Expertise is rare, very expensive. So if we can digitize that and put that into the cloud, I think it can have a very fast and profound impact. As you know, soon as you digitize something, digital photo, you change totally the size of the market and the impact. So our focus is to digitize expertise and knowledge to have a thinking system.
I'm assuming you're not the only one thinking about this way, or are you?
There are projects like Seek and so on to do that. But like I said to you, first of all, you have to have a technology that has to have at least two things. One is how to break down the complexity of the knowledge acquisition. And the second thing is be able to handle multi-logic. So ThinkingNode technology is a new technology that just does that. And then you have to have a business strategy to get there. So from here, how to get there. So
are you wearing two hats then, sort of CEO, CTO?
Yeah, and I love programming, and I will keep programming because it keeps my mind sharp. I realized that when I stopped to program, I didn't think the same way. So I will be a CEO that is quite technology.
Yes. How large is the ThinkingNode team right now?
Yeah, so we are about 10 people for full time, and it's why we are looking for now hiring people. So if I may use the opportunity, yeah. So we are looking for people who really want to learn reasoning computing, which is the next AI market, and we are looking for people who love complexity, who are genius with the extremely low ego. So this is the combination that we are looking for. And
sounds like I should apply. What about if you're extra genius but with slight ego?
Okay. All that is relative. So
yes, no, that's great. Now I've like I said earlier, I've observed your journey, and I'm extremely excited about it. I do have to ask you though about sentient beings and where this is all going. With the two camps around, people who think AI is mostly harmless and others who think it's the future of the dystopian world. Just tell me what your thoughts are.
Yeah, I'm extremely optimistic person. So if you see the beginning of humanity, our brains spend most of our time to remember things because we don't know how to write and so on. So all the energy is focusing on remember. Now that we have all that, all the energy is more focusing on the reasoning and thinking. And then maybe ThinkingNode or other company is going to bring the reasoning things of it. So we think less and less. So the question is, what can be the post-thinking era? So it's very difficult to think about it because it's a post-thinking. So if you're still thinking about it, you are not in this concept. And why so important is because each time you think, you have to discretize the different concepts. So let's say I say, this is a cup of coffee. No, it's a cup of coffee with Etienne. No, it's a cup of coffee, Etienne, during the studio, and so on. So if I want to be very precise about that. But if I'm doing that, I cannot think because I cannot connect that with another concept. So I have to discretize already the information of the cup of coffee, which means I lose already a lot of information. So thinking start already with so much little information. So we cannot go very far. So I believe that AI, machine learning, and reasoning computing is going to help us to go faster to the post-thinking era.
And do you think it's like kids who don't really need to, do arithmetic because they have a calculator? Is it the same, or is it not quite the same? So, for instance, when I was at school, you weren't allowed to take a calculator to school. Now, you're a fool if you don't take a calculator to school.
Absolutely. For me, once you understand the logic, you don't need to remember, machine is going to do that. And maybe at some point, you don't even need completely to understand the logic because you're going to think at another level.
Yes, because you're going to stand on the shoulder of this thinking giant. Okay.
But the post-thinking era is totally another species. because it's no more built up on other concept, because then you're still at the concept level, which means you're still discretizing things, which means you're still losing information, which means you cannot.
Is that why associative memory is so powerful? Because we aren't remembering the cup necessarily if you leave here. But when you remember that you were with me in a studio, then your brain sort of unlocks, oh yes, there was a cup, and oh yes, there was this fragrance, or that association that happens. Is that what you're referring to?
Yeah, I guess it's like when you listen a very nice piece of music that you love long time ago, right away it brings you back at that time.
Yes.
So it's not so analytical, discrete. It's more continuous experience things. So I have no idea what it's going to be, but I'm very excited that machine is going to help us to get there faster, because we don't need to reason.
Yes, and it's and you're saying in a way we don't know yet what we don't know, but you're super optimistic about what that's going to look like.
Well, people say we are using 10 or 20% of our brain, which is true and false, because we are using 100% of our neurons, but our neurons is probably 10, 20% of our brain. So what are the other cells doing? In particular, the glial cell. We know very little about the glial cell. So maybe they're going to, wake up, or I don't know.
Oh, that's amazing. That is amazing. So do you think we're going to have sentient beings, or do you think we're going to have the singularity?
Oh, yeah, there's no doubt. However, for me, singularity is, the way I see it, it's the new way that nature have found to accelerate evolution, and it's called technology. So nothing we can do about it. It's part of evolution.
I love it. Khai, this is something we could talk about for days. And the final question I have for you, and we'll post some notes, and people can read up on your history. Do you know the song Etienne, Etienne, Etienne?
Yes.
Cool.
Very nice song.
Okay, Khai, well, thanks so much for joining us, and we'll post some details about ThinkingNode so that we can, get some candidates your way, and we wish you the best.
Sure.
Thank you very
Thanks
much.
a lot to give me the opportunity to talk.
Absolutely. Have you chatted with a CTO lately? Hi, thank you for listening to the CTO Studio. If you don't mind, take a quick second and please rate and review the show. It helps us a lot. Go to the ctostudio.com for more information on what we're doing at 7 CTOs. We also have a video or two for you that could be a helpful resource for you as you're managing your company. So thank you for listening.